All right, this is assignment number 3 in our first unit in Algebra 2. We're going to be talking about absolute value. We're going to be solving absolute value equations as well as absolute value inequalities, and then apply an absolute value inequality to a certain situation called a tolerance situation, which we're going to get into during this video. Let's go ahead and get started. So you did in Algebra 1, you guys were solving absolute value equations that look something like this. And let's just go through, and you can try these on your own before we start, but let's just go through each of these to make sure that we know what we're looking for here. First thing I'm going to do is get the absolute value part completely by itself. So I'm going to start here by adding 7 to both sides so that I have 3 times the absolute value of x plus 4 is equal to 27. Then I'm going to divide everything by 3 so that I can just have the absolute value completely by itself. So now I have the absolute value of x plus 4 is equal to 9. Now, at this point, we know that if I have the absolute value of a number, and let's say that it's equal to 9, there's 2 things that n could be. N could be 9 because the absolute value of 9 is 9. So n could equal 9. But another thing that n could be is negative 9, because what's the absolute value of negative 9? Well, that's positive 9, because both of those numbers are 9 units away from 0. So we're going to apply that same thing here to this equation. The thing that's in the absolute value is x plus 4. That could be 2 things. X plus 4 could be 9, or x plus 4 could be negative 9. And so I'm going to solve both of these equations. If I subtract 4 from both sides here, I'll have 9 minus 4, which means x is 5. And here, if I subtract 4 from both sides, I'll have x is negative 13. And we could plug both of those back into our equation to make sure that it works. If I start with the 5 first, I know that 5 plus 4 is 9. The absolute value of 9 is 9 times 3 is 27, and 27 minus 7 is 20. So this one works. I can do the same thing with 13. 13 plus 4 is 17. 17 times 3 is, no, that's negative 13. So negative 13 plus 4 is negative 9, and the absolute value of negative 9 is 9. 9 times 3 is 27, and 27 minus 7 is 20. So this one works also. So we get 2 solutions here. So let's go on and take a look at number 2, because number 2 is a different situation. It has both an x inside the absolute value and an x on the outside of the absolute value. But we're going to start it the same way. I'm going to start by trying to get this absolute value isolated. In other words, get the absolute value by itself. And I'm going to do that by dividing both sides by 2. And so when I do that, I'll have the absolute value of x plus 3 is equal to 4x divided by 2 is 2x, and 24 divided by 2 is 12. So just like over here, when I wrote 2 separate equations, I'm going to write 2 separate equations here because there's 2 things that x plus 3 could be. X plus 3 could be exactly what it says that it is, which is 2x plus 12. But also, x plus 3 could be the negative of 2x plus 12, which is negative 2x minus 12. So I'm going to solve both of these equations. If I take a look at the first equation, I'm going to subtract 3 from both sides first. And, well, maybe I won't do that. Maybe I'll subtract an x from both sides. So this x is gone. 2x minus x is x. At the same time, I'm going to subtract 12 from both sides, so that'll disappear. And then 3 minus 12 is negative 9. So it looks like negative 9 is one solution. Then if I go over here, I'm going to add 2x to both sides. So if I add 2x to both sides, x plus 2x is 3x. At the same time, I'm going to subtract 3 from both sides. And so I have a negative 12 minus 3. Well, that's negative. I have a negative 12 minus 3, which is negative 15. And then if I divide everything by 3, well, then I have x is equal to negative 5. So it looks like I have 2 solutions. But let's just plug both of these in to make sure that they both work. I'm going to start with a negative 5. Negative 5 plus 3 over here. Negative 5 plus 3 is negative 2. The absolute value of negative 2 is 2, and 2 times 2 is 4. But when I plug negative 5 in over here, I get 5 times negative 4, which is negative 20, and negative 20 plus 4 is also 4. So I have 4 equals 4, and this works. But when I plug in negative 9, you're going to find something that maybe surprises you. It's not going to work. Let's just try this real quick. If I plug in negative 9 on the left side of the equation, negative 9 plus 3 is negative 6. The absolute value of negative 6 is 6, and 6 times 2 is 12. So I get 12 when I plug it in on the right-hand side. Sorry, it's so sloppy. Then if I plug it in over on the right-hand side, negative 9 times 4 is negative 36, and negative 36 plus 24, well, that's negative 12. Well, negative 12 and 12 are not the same thing. This does not work. This is called an extraneous solution. An extraneous solution is a solution that works when you solve it, but when you plug it back in, it doesn't work. We're going to talk about why it doesn't work next. This is not considered a solution. The only solution for number 2 is that x is equal to negative 5. Well, why does that work? Let's take a look at this situation. If I have 3 situations, A, B, and C, and the first situation is that I have an absolute value that's equal to a positive number. Remember that the absolute value is how far something is from 0. So on a number line, if I have 0 right here, I'm talking about something that's 5 units this way and 5 units this way. It could be 5 if it's 5 units to the right, and it could be negative 5 if it's 5 units to the left. So this solution A has 2 solutions. Now, if you take a look at B, the distance from 0 is negative 5. Well, how can you have a distance that's negative? Even if you go in the opposite direction, it's still a positive distance. So if you have an absolute value that's equal to a negative number, that doesn't make any sense. Here, there's no solution. Here we have 2 solutions. Here, there's none. We don't have any solutions. And then for part C, if I have a distance from 0 that's 0, well, that means it's 0. There's only one solution here, and that's 0 itself. And so sometimes we're going to have 2 solutions if it's equal to a positive number. If it's equal to a negative number, we're going to have no solutions. And if it's equal to 0, we're only going to have one solution. Well, how does that bring about an extraneous solution? Well, if we have this absolute value and we get a value for x that let's say is negative 8, well, if we have x being negative 8, that means the absolute value is going to be equal to negative 8 plus 7. There's my dog. Negative 8 plus 7 is negative 1. Well, you'd have an absolute value that would be equal to a negative number. That won't work. So when we solve this equation, we're going to hope that both of our values of x make this right side equal to something that's positive. And if it does, we're going to have 2 solutions. If it's negative 7, we're only going to have one solution. But if it's anything, if I get an x value that makes the right-hand side equal to something that's negative, I'm just not going to have a solution. Let's just try this one out. I would set up 2 equations here. The first one is that 2x plus 5 really does equal x plus 7. And the other one is that 2x plus 5 equals negative x minus 7. Well, on the one on the left, if I subtract an x from both sides, I will have x over here. And if I subtract 5 from both sides, x would be equal to 2. We're going to try and see if that works here in a little bit. Over here, if I add an x to both sides, I'm going to have 3x equals, if I subtract 5 from both sides, negative 12. And if I divide by 3, I'll get that x is equal to negative 4. Well, I think both of these are going to work because when I plug a 2 in here for this x, that's going to give me a positive 9. And if I plug a negative 4 in here for this x, that's going to give me a positive 3. So I think both of those equations are going to work. So we can try them out and you'll see that both of these equations work, or both of these solutions work, and so I don't have an extraneous solution in this case. But if I would have had something that x equaled a negative 8 or a negative 9 or negative 10, something that would make this side equal to a negative number, then I would have an extraneous solution. So that's something you have to watch out for whenever you have a variable on the inside of the absolute value and a variable on the outside of the absolute value. We're going to move next on to solving inequalities. But to do this, we're going to take up some extra time here. This is about a 10-minute video. I'm going to pause the video. This is going to be part 1, and then we're going to move on to part 2 here in a little bit. So we will move on to part 2 of the video to continue this PowerPoint.